Welcome to my pitch for the competitive hacking game Flux. In Flux, players take on the roles of either cybersecurity agents looking for fluctuations in a fictional network, or hackers looking to distort the system for their own personal needs. Agents must use their detection tools to find the hackers and then use security measures to trap and capture them. However, the agents can only see the effects of the hacker's actions. A hacker's exact position on the map is unknown to the security agents. However, any action they take will cause a small fluctuation in the network that security agents can detect. In Flux, the security agent's objective is to trap and capture the hackers. The security agents win if all of the hackers lose, are captured, or surrender. The security agents fail if any of the hackers can complete their objective. Vice versa, hackers must achieve a particular goal that is unknown to the security agents. The hackers win if any hacker achieves this goal. The hackers lose if all the hackers are caught or surrender. The antagonizing force in Flux is always the enemy team. If you're a hacker, the antagonizing forces are the agents, and vice versa. However, the antagonizing force can be a human opponent or an AI opponent, depending on the game mode. In addition, some objectives may be timed, making time an antagonizing force in these situations for both the hackers and security agents. In Flux, players must make meaningful decisions based on the current situation. For example, a security agent must be aware of the difficult decision of choosing how heavily to inspect an area. Checking a single area heavily can give an agent a reference point of where the hackers have been and can use this to suss out the hacker's path. Inspecting a large number of areas lightly can find a hacker who is rushing to get to their objective. Hackers have a similar dilemma. For hackers, every action leaves a mark in the space, and the more impact an ability has on the game, the more of a fluctuation it leaves. As such, hackers must balance the reward of a large or small move with the risk of detection as a result of the fluctuations. Flux takes place in the near future, where everyone works and plays using digital interfaces. Naturally, this means that hacking has become a rampant crime in the new age. Hackers are constantly looking to get in companies' information for a variety of reasons. And many corporations have hired cybersecurity agents to catch and stop these hackers. The viewing perspective for Flux is 3D. Play takes place on a galaxy map, similar to gameplay in games like Mass Effect or Spore. The nodes on this map represent the devices that are accessible to both teams, and the lines between them represent connected devices they can use to travel around. The most relevant games deal with the hacker side of gameplay. These games show how gameplay might run in Flux for the hackers. Flux will be similar to Hacker Experience, where the player doesn't need to know code to play, and instead uses a set of steps to activate their hacking abilities. The game would also use an art style similar to HackNet, where there is a black background and very wildly contrasting colors in the foreground. Flux creates an interesting gameplay dynamic between the hackers and security agents. The hackers must use deception and misdirection to keep the agents from finding them before they can reach their goal. For example, the hackers can create fake fluctuations that will disappear after a certain amount of time to throw the security agents off their trail. Security agents must use communication and deductive reasoning to trap the hackers and stop them from achieving their objective. The main risk of Flux is not being able to find a good balance between the powers of each team. If either team has a major advantage, it will feel very unfair to the other team. The best way to mitigate this problem is to set up ways for the designers to easily collect play data and playtest heavily.